All right, guys, so if you remember from the first section of this unit, what we talked about in our most recent video, we were looking at both the area and perimeter of some of the basic shapes and figures that we're going to take a look at in geometry. Obviously, we're going to spend a little bit more time with that. We're going to start to take a look at some of the special cases. In fact, today we're going to look primarily at circles. So we're going to look at what are called the areas and sectors of circles, and kind of figure out how to find the area when you don't want necessarily the entire circle, but maybe just a piece of it. So just as a reminder, the formula for the area of a circle is the area is equal to pi r squared, where r represents your radius. All right. So we're going to look at some basic examples first, and then we'll look at some more complicated cases later on. For the first one, it's going to be pretty easy. It says find the area of the following bold figures, giving exact values. In this case, the bold area or the bold figure is going to be the entire circle. So pretty simple for this one. We're going to go ahead and just plug in our information. So remember, area is equal to pi r squared. So then area would be equal to pi multiplied by 12 squared. And 12 squared is 144. So our area is 144 pi. Now don't forget your label. Our label was centimeters. And then remember that for area, that becomes centimeters squared. So that would be 144 pi centimeters squared. Now, if you wanted to kind of understand a little bit better how big that was, you could also find it as a decimal. It ends up being about 452.4 centimeters squared. So obviously, remember, our answer that we're going to leave it as is the exact answer. But if you wanted the decimal and type it into your calculator, it's about 450, a little bit more than that, centimeters squared. Now, if instead of the entire circle, it just wanted that piece where it says 12 centimeters, it just wanted the radius, then it actually becomes 0. So if you just want the area of a line segment, remember that's going to be 0. But obviously, if it wants the entire circle, then it's going to want you to just do your normal area formula. All right, let's go and take a look at this next circle. So in the next circle, we've got our 13 centimeters for our radius. And this time, for the bold figure, we only want this piece right here. So we only want that piece, which it tells us is 90 degrees. Now, something to think about is how much of the circle is that. And if you can't tell just by looking at it, maybe these extra lines will help. But that ends up being 1/4 of the circle. And that's because 90 degrees is 1/4 of 360 degrees. So that piece is 1/4 of the circle. So our area formula just looks a little bit different. We're still going to have the pi r squared, but then since we only want 1/4 of that, we're going to multiply by 1/4 at the end. Okay, so let's go ahead and plug in our radius r. So that would be pi multiplied by 13 squared, and then multiplied by 1/4. And then remember, 13 squared is 169. Multiply by 1/4. And then to make this look a little bit cleaner, what we're going to do, the 169 and the pi are going to multiply with the 1. The divided by 4 is going to stay in the denominator. So our final answer here is going to be 169 pi over 4. Which we can simplify just a little bit. If we wanted it to be as a decimal rather than a fraction, we could call that 42.25 pi, or we could approximate it to get a decimal. It ends up being about 132.7. Now, in all of these cases, we do need a label still. Once again, it was centimeters. So this would be centimeters squared. So this is probably the answer we'll stick with, but if you wanted to, this next answer right here is good as well. And again, remember, approximating is just if you're curious, really not something that we're going to really do a whole lot of. We prefer the exact answer. All right, for this next example, we're going to do kind of the same thing, But now instead of looking at the 90-degree part, we're looking at this larger part where it was 270. So that would be this part kind of right in here that I've got shaded in. Which, if you notice, instead of being 1/4 of the circle is the other 3/4. So just keep in mind 270 is 3/4 of 360 degrees. So that shaded in area is going to be 3/4 of the circle. So just like we did before, we're going to start with our normal kind of area formula, so pi r squared, but then we're going to multiply it by 3/4 at the end. So in this case, when we plug in r, it actually also ended up being 13. So that would be 13 squared multiplied by 3/4. And that becomes 169 multiplied by 3/4. Which, to simplify that just a little bit, let's go ahead and take 169 multiplied by 3, which is 507. So that would be 507 pi, and then the 4 will stay in our denominator, and then there's going to be our final answer. Now the label in this case was feet, so we're going to have that as feet squared. And if you wanted to find the decimal approximation, it ends up being about 398.2 feet squared. Okay, so those are some kind of basic examples of what we call sectors of a circle. But we're going to get into some more complicated cases where it's not going to be a nice like 1/4 or 3/4, but a different size piece of our circle. So let's talk about what a sector is, give it a more formal definition, and give it a little bit better formula. So a sector is the region inside the circle that's formed by 2 radii, which remember radii is the plural for radius, and the intercepted arc. So a sector is a part of a circle. You could think of it as being kind of a slice of the pie. Now the area of a sector is going to be found by using the area formula for a circle, but then also taking into account how much of the circle that we are looking at. So for the area of a sector, what you're going to do is you're going to take whatever your angle is divided by 360. So you're going to figure out kind of out of 360, how much of the angle are you looking at, and then multiply that by pi r squared. Okay, so let's do some examples using that formula just to get a better idea of how that works. So, in this first example, we've got our 90-degree angle. So there would be our angle itself is 90, and then we've got our radius, r, which is 12. So in this case, remember area is equal to our angle over 360. So that would be 90 over 360 multiplied by pi r squared. So pi and then 12 squared. So simplifying just a little bit, if you simplify 90 over 360, they are both divisible by 90. That becomes 1 over 4, which should make sense. Remember, we did one like this before where we talked about a 90-degree angle being 1/4 of the circle. It won't always simplify that much, and feel free to use a calculator. Remember, the Desmos calculator can help you with simplifying. But then multiplied by pi, and then 12 squared is 144. So now everything that is on the top of the fraction or in line with itself, so the 1, the pi, and the 144 are all going to go in our numerator, so that's 144 pi. The 4 is the only thing in our denominator. And then it turns out that you can actually divide 144 by 4. That ends up being 36. So our answer is 36 pi. Now in this case, there weren't any units. Sometimes you could just write units squared, or in this case, you could just leave it blank. It really doesn't matter. But if you did want to find a decimal approximation, type it into your calculator. It ends up being 113.1. Okay, let's take a look at another example here. So in this next example, we've got a 30-degree angle, and we've got 4 centimeters as our radius. So putting those into our area of a sector formula, we're going to say area is equal to our angle, which is 30, divided by 360, multiplied by pi r squared, so pi, and then 4 squared. So now simplifying 30 over 360 ends up being 1 over 12, multiplied by pi, and then 4 squared is 16. So remember, everything on top goes in the numerator, so 1 multiplied by pi multiplied by 16, which is 16 pi. The 12 stays in our denominator, which then you can simplify this just a little bit. So 16 and 12 are both divisible by 4. This becomes 4 pi over 3. And then we include our units, which were centimeters. And remember, now they are centimeters squared. Once again, if you want to find a decimal approximation, it ends up being about 4.2 centimeters squared when you type that into a calculator. All right, let's take a look at 2 more examples, and then that should be it for us today. All right, so in this next example, and remember, formula stays the same. You're taking your angle, which is 110, divided by the entire circle, so 360, multiplied by pi r squared, so pi, and then 6 squared. As far as simplifying goes, 110 over 360, they both end in 0, so they're at least divisible by 10. In fact, that's the largest thing they're divisible by. That would get you 11 over 36, multiplied by pi, and then 6 squared is 36. Now, to make simplifying just a little bit easier, here's what we're going to do. Let's go ahead and put the 11, the pi, and the 36 all in our numerator. In fact, I'm going to write that as 36 multiplied by 11 multiplied by pi, all over our denominator, which is 36. Now, normally we would multiply the 36 and the 11 together and then try to simplify, but I did want to show you something, and the reason why I didn't do that is that notice that now you've got 36 in both numerator and denominator, so those are going to cancel with one another, and so our area ends up just being 11 pi. In this case, our label was feet, so 11 pi feet squared. Which again, if you wanted to know what that would be as a decimal, it ends up being about 34.6 feet squared. All right, one last example that we are going to look at, and we do need to be careful with this one. Although the angle is labeled as 60 degrees, we are actually interested in this angle right here in the shaded portion of our circle. Now, to get that angle, remember that circles have a total of 360 degrees. And if we're already using 60 degrees for the angle that's in the unshaded section, then that leaves us 300 degrees as our angle for the shaded section. So that'll be the angle that we end up using, is going to be 300 and not 60. So when we put that into our formula, we have 300 as our angle divided by 360 multiplied by pi r squared, so that's pi, and then 8 squared. So now as we simplify this, 300 and 360 are both divisible by 60. That leaves us with 5 over 6 as our fraction, multiplied by pi, and then 8 squared is 64. All right, so now simplifying just a little bit, if we were to multiply everything in our numerators together, 5 multiplied by 64 is 320, multiplied by pi, all over 6. And then to simplify that just a little bit, both of those are divisible by 2. So that gives us 160 pi all over 3. And in fact, that is as much as we're going to be able to simplify. It didn't have units, so again, either leave it blank or just call it units squared. And there would be our final answer. If you did want to know what that was as a decimal and type it into your calculator, it does end up being about 167.6 units squared. Okay, that is all we've got for today, guys. In the next video, we're going to be talking about areas of composite figures, which are basically when you have different shapes that have been put together to form some other shape that's not a normal shape. Until then, guys, have a good rest of your day.